Welcome to another Observability Clinic. Today's topic, a practical guide to DQL for metrics. I have the metrics expert with me as it comes to DQL. Fabrice, bonjour.
Hello, bonjour.
Thank you so much for being here. It's a hot topic because we're adding more and more of our data into Grail, making it accessible through DQL, the Dynatrace Query Language. And I invited you to show us how DQL actually works in order to get access to the metrics and get answers out of it. Fabrice, the floor is yours. I know you've prepared a lot of content and also some demos, so please walk us through it.
Thanks, Andy. Thank you very much for having me. So today what we're going to go through is a metrics refresher. We've already seen some demos on Observability Clinic around metrics. I want to do something that is a bit more in depth to explain the structure of the time series, what it is actually. Hopefully, it's not going to be too much, and then some more examples on how to use DQL, and possibly a bit more into the detail, and showing also the latest feature like calculation between metrics, and then a quick recap and some resources so that you can look in your own time into the documentation, the examples that we have, as well as the content that we have today on the platform.
Perfect. Thank you.
So metrics refresher. So this is something that I took from my colleague Peter Zauer. I remind you that it's not just metrics, but the whole platform is about what we call Grail, this Dynatrace data lakehouse, and one of the big plus of Grail is to put everything into all the content that we have, entities, metrics, events, logs, and traces, into one single place, and no more silos. So that's a huge benefit. And in front of this Grail lakehouse, you have one single query language, which allows you to not only use the same language to query all this data, but also to mix and match this data. So this is really a unique feature that we have that is really making a difference when it comes to Dynatrace. So I refer you to a presentation that Peter gave, Peter Zauer, who is my colleague in the team, who is looking after DQL as a whole. Today, what we're going to look at is only metrics, right?
Perfect. And Fabrice, for everybody to know, we will also link the presentation from Peter in the description of this video. So in case you want to go back and watch the introduction session from Peter on DQL, just look at the description of this video and you will find the link.
Yeah, I watch it. It's a great video, so I recommend that. It will give you a larger picture of what DQL can do. And again, as I said, today it's time series, it's metrics only. So what is the metrics? Metrics are a bit of a slightly different animals compared to logs. If you think about logs, it's really one in, one out. You send a log line into Grail, you get a log line. There is a one-to-one relationship. When it comes to time series, it's not. When it comes to metrics, it's not exactly the same. What you ingest is not going to be exactly returned the way you ingested it. And why? Because otherwise it would be too much, it would not scale. So what is a time series exactly? So when you see a time series from the outside, maybe I'm going to use the laser. Yeah. From the outside, a time series is something that we're familiar with. It's dimensions. So it's all the information that is giving you context about your log line. So log level, where it's coming from, timestamp, etc. So we have this, we need to qualify each series. But then actually a time series, a matrix, is better expressed as an array of numbers, okay? And the best way to represent it is to show you the full array on a single row, right? That's the key difference when you're thinking of metrics, people tend to make the confusion. So it is really important to understand that a metric is always a suite of number, which is defined by the parameter that you use. And this array of numbers, they have some characteristics, some properties that are really important. And then, since it is a series of number, it's actually between a start and an end. So you have a time frame start and time frame end. It's the time definition of each series and an interval, which is defined again by your parameter. And what is important to understand is that the data has been aligned, right? So each row is a line on your graph, and each point is a line and it represents a certain something. And so this is what you would get, for instance, if you are doing a time series request, when you are saying, I want the average of a certain metric key, and I want to split by, I want to aggregate by certain dimension. Here it's cluster name and the ID of the cluster. And we define, so this is, I put it here, the from 24 hours, this is not typical that you use it, but it's to say that because of these 24 hours, time series command has decided that the best interval to make it manageable would be a 10-minute interval. Okay, so this is what you get on the outside. And again, if I want to go away with one thing is each row is a full array of number. Whether you want to reduce those numbers later on, it's absolutely a valid use case, but you always start with that.
Mm-hmm.
Okay.
Fabrice, just so that I also understand, I think this is an awesome explanation. And if I look at the time frame start and end, I can see here that's from the 26th until the 27th, the 10-minute interval. That means if I do the math, the request CPU probably has 24 hours times 6 metrics per hours. These are the number of then data points I have in that array.
Yeah, and so you're touching you're absolutely right to raise the question. It's actually, you will get most probably 1 point more because we don't know, you are going to do this request at any time of the 10 minutes, right?
Yeah.
And we don't want to give you missing data. So we're going to slightly extend so that we match the 10 minutes, and we're going to align on multiples of the hour, okay? So you might have done this request at 9:20, 9:21, 9:22, 9:30, 9:29 and 59 seconds, but we still need to align also for consistency reason. So if you do this request every 1 minute, you're still getting the same data. You're not shifting constantly, and this is the added value. So in effect, what it's going to do, it's going to give you 1 point more from time to most of the time, right? So you are going to get 24 times 6 plus 1.
Okay.
Okay.
Cool. Thank you.
And that's because we want to. Otherwise, we would truncate one way or the other, and we would not be covering your full time frame.
Yeah, understood. Thank you.
So next, if you want to switch, okay. So what's happening underneath? And what I want to again, do a bit of a lecture on time series is what's happening under the hood, and it's the reason why we have a time series command that is a bit beefy compared to fetch logs or fetch events. It's because we need to do this upfront, okay? So you have to imagine that underneath the data, I told you, it's ingested and then it's optimized, it's messaged. So you have to imagine that your one cluster that I showed before might have been several nodes, yeah. So you still, although it shares those Kubernetes cluster and beta that are in bold, and underneath there were more node names. Okay, so this is very understandable. It's an aggregation, and you're saying buy something. But also the values here, I'm showing plenty of nulls, you see, and that's because the data is not well aligned necessarily. The way you might have holes, the timestamp might be all over the place, and this is the reality. We don't know. Sometimes the sensor does not send data, but the value, and so it's maybe not 10 minutes apart. It is 5 minutes apart. Sometimes it's arrived at 59 seconds. Sometimes at 1 second after the dot. So, and we don't care. What we want is properly arranged metrics so that we can graph it and we can show things that are consistent. So what time series does is it's going to aggregate all these raw values. And by the way, these raw values, I'm showing numbers here, but it could be distributions. It could be an histogram. So think a response time. We're not going to store every little response time for each query. We're going to say, okay, we got 10 data points that were between 200 milliseconds and 300 milliseconds, 20 data points. So, and this we could not represent, but we still need to do aggregation, percentile, median, 95, 99 response time, etc. So there is no point showing it's counterproductive to look back into the data as the way it's stored. It is our cuisine, and the point is that time series is going to rearrange this and to give you this proper data. So that's why we have this concept of time series with a few parameters that are necessary to do the job. Okay, and so if I put this into all the things that time series can do, you need at the bare minimum, these are mandatory, a metric key, obviously, and an aggregation, average, sum, count, percentile in the future. We're going to have percentile very soon. And you have the aggregation dimensions. We need to provide this. So it's contrary to fetch logs where you would summarize later on. Here, you can provide it upfront. And then the filter is also something that you can do within the time series. I will explain in which case we need that. Okay, so that's the absolute minimum that we need to properly do our job. And it's actually what you would also do in other languages like PromQL or our second gen metric selector, etc. So where we are going to improve over our previous state of the art is that we try to condense everything into the time series to have a kind of fetching phase, and then we go back into this great way of adding value that we have in DQL using the pipes. Okay, so this is what Peter explained very well in his presentation. You do your query, and then you start adding more value by doing more transformation. And we keep this philosophy, one time series request containing everything that you need to do that belongs, before in the fetching and aggregation phase. And then I'm giving here 4 examples, and I will go through this through the demo, where you're going to say, okay, actually, I'm not interested in a time series. I'm not charting the data. All I want is the max of each line. Okay, and that would be another pipe command that we would say, okay, give me the last number of the time series, and that would be good enough. And we would not chart it. We would just show a table. Same thing, if we want to sort, we're saying, okay, we have tons of data, tons of lines, tons of hosts, let's say. I want to get only the top three clusters. So here I would put a sort function. If you want to, so I always took the approach that we had only one metric, but very often from you have a screen and what you want to show is not a metric per se, but more like a host. You want to show everything that is relating to this host, whether it is logs or metrics. And in that case, you're using the append command to have several metric key for the same host. And then same thing, and this is what is just out of hot from the press, is querying several metric key and then combine them using mathematics, right? To do some ratios. So this is the end of the of the lecture, and I'm going to put this into action if that's okay.
That's perfect. Yeah. Thank you so much also for these examples, because the examples always really help to visualize what is the use case and how does this then translate into the query. Yeah, go ahead with the demo. Let's see it in action.
Okay, so I'm here now in a notebook. So again, I told you this is going to be DQL heavy. Everything will be done using DQL. I found DQL extremely easy to use, and you know, it's very natural. Yeah. But at the same time, I'm doing this all the time. I know that we have users out there who are saying, well, okay, but it's a new language to learn, etc. Blah blah blah. I have another colleague, Thomas Ziegelbecker, in our team, who is looking at providing a visual aid to create those queries to the point where you won't need actually to write code. Okay, yeah. So we hear that, we know that. We have this also in our classic offering where you have two modes in the Data Explorer. So don't worry, we're covered. Yeah. But at the end of the day, I prefer to use DQL, and this is what I'm going to show in the notebook. Okay.
Yeah, I think it's also great to show the basics, that everybody understands the language. And besides what Thomas is putting in to make it easier by point and click, we also announced to the world Davis Copilot. So Copilot will also then help you with just a human language, and you can then query data with a human language interface. Yeah.
Okay, cool. So again, with DQL, you will have a full power.
Full power, yeah.
You won't get as full power with what Thomas is doing than with the hardcore DQL. Okay, so where I'm going to query Grail, I will use time series. I will say I'm interested into the one metric that everybody uses, which is your host CPU usage. I need the average host.cpu.usage. This is the most basic thing. So I told you your aggregation, your metric key, and you get your graph, and this is the average across all hosts. I don't know how many hosts I have, but I have something, right? So here I want to start showing really what we meant by it's a series, and so I'm going to use the option to show the record list, right? And so you see here, you see the exact fields that I showed, and there is no dimension because I did not specify a by. So you have your start and your end. You have the interval that was been chosen. So I'm on the last 2 hours. So it's a 1 minute interval. And then I have this array of the numbers that are being shown. If I go into table mode, it's going to be something similar, but the interval is represented in nanoseconds, so it's very difficult to read. So I prefer to use record list, but you get the idea. Start and your interval, which this is 1 minute, and the numbers. But you see, it's your 121 numbers, as we said, 2 hours, 120 minutes plus 1 to adjust, because you were not guaranteed to unless you did it on the second. Okay. So if I go back to record list, and if I change to 1 day, let's say, and I do my query again, fine. It's going to do another calculation, and it will say, okay, 10 minutes. Makes more sense, and your line chart is going to be there, right? But this now is over 10 minutes. It has adjusted the interval. 7 days, same thing. So I'm showing it here because, and here you see 1 hour interval. Okay. So this is very, very classic. If you want, you can change the interval to 6 hours, let's say, and your line chart would be a bit coarser. right?
Yeah.
Sometimes people want to sit. So if you wanted to do last minus 30 days, maybe it would make sense. And by the way, if I or I could put a 1 day here. And I have my CPU. And you see, if you look at the time, it is well aligned on the beginning of the day. It's irrespective of the fact that I did it at 9:39 in Vienna, and so and aligned to my time zone. This is something that we hear all the time. I want it aligned on my time zone. Yeah. So here we are aligning correctly on each hour. If I go back, if I remove this, then again the default. If I want to go roughly to a number of 120 data points, which is what we recommend for a chart, then here it would be 6 hours. But so you see, you can change this parameter, and you see that we have aligned the start and the end time. Okay, so we'll go back to 2 hours, and we go now to this concept that we can split. We can split the data because, you know, our CPU usage is not telling me a lot. So I know that my hosts are running on AWS, so there are regions, and you see it has been averaging across each region. So here we can do the classic things that we have in the notebook. So I can filter if I'm interested only in US East. And here we go. So it had added the filter, and we're going to go in detail on what it means, a filter after or before. So if I continue and I want to see each of my host name, so now I have plenty of hosts. Actually, I have 18 hosts within this region. Okay, and if I want to, I see this big one. And maybe I'm going to filter on the host name. And now you see, I have narrowed down using the and without, by the way, typing DQL, it was generated.
Whole point and click. Yeah, no, I know, it's awesome. Yeah.
Okay, so you see here that we can filter after, you know, and I told you, yeah, but we want to filter before. So why do we need filter before, right? So let's say I'm interested into this host. So I'm going to remove this one, and I'm interested into those hosts that are internal. So you can type more complex query than just equals, obviously, right? Host name.
Maybe in a different region.
Yeah, it looks like. There we go. Ah, yeah, it was US East, you're right. US East, okay. So I'm going to filter here. So now within US East, I have this 4 host name that contains internal. Now, if I wanted to, and this is the typical mistake that everybody does, if in the first place you actually wanted the average across the region, and you want to do this filter, then you see here, and so if you want it to be like this, if this is what you wanted to do, then you get an error because there is no more contains name intervals. Okay, so this is why you need to pre-filter the data, and if this is what you wanted to do, then this is why we need to put this filter before, and this is why we have this filter option where you want to filter by something and aggregate by something else.
And that's also for me to understand, because in the previous example, basically the time series command was returning all the data of all the hosts grouped by region. And then on that data set, you are filtering. Now, by putting the filter in the time series line, already when Grail is executing the query, it's already doing the filtering in the first batch. That's the big thing.
So this is quite important, I would say. Not always, but it's necessary. Let's put it that way. Believe me. Okay, so that's the I would say the basic where we understood how it works. We understood that. So again, if I remove this this filter. Yeah, but now I actually no, I have to also remove this filter. I want to just remind us that we have those 3 lines, and if I go to the record list, now I have the AWS region as part of the field, you know, and this is what I told you. It's we are not showing you each timestamp. We're showing you the full thing. So you have 3 rows in the chart, and you had 3 records, right? And in the table, same thing. 1, 2, 3.
Makes a lot of sense. Yeah.
Okay. So, but it's obvious like this, but I want to mention it, that it's something that is a bit special, that is much better in my view. And the way we're doing it is, the way we do it is because DQL is so powerful, we can store complex objects. So arrays, JSON, and we wouldn't be able to do it with our previous generation. Okay, so now I told you I want to go to, this was like, I'm going to accelerate a little bit and talk about the arithmetics, which is the things that I really like these days.
Maybe
so now,
maybe I wanna, if you wanna share this later, Fabrice, do you mind scroll down and create a new query? Yeah, perfect.
So here I typed very quickly. I copied it. What I'm doing is, it's a typical use case of metrics arithmetics. You know, it's nice to chart, but at the end of the day, to chart one metric, but what you want to do, if you want to do really powerful thing, is you want to do SLOs, you want to do ratios, you want to message your data. So what you need to do is to query multiple metrics and to combine them, right? And so for this, you're going to very classically send your instead of doing request CPU equals something, you will do this and that, okay? And I'm putting some nice names so that my calculations are going to be nice. And your buy as usual. And here is the magic happening, where you say, okay, so you have to know your metrics, obviously. And in these metrics, you have what is being requested in millicore versus what is allocatable. And you get an idea of how stressed or not stressed your cluster is by doing the ratio of the denominator, the numerator is what is being used, request CPU, and what is totally available, which is what you have used plus what is left. Okay, this is CPU allocatable. So here you see something that is not so nice. So you see, I put this mathematical expression, but what this mathematical, so you notice that we're using this bracket thing here to say it's not just scalars, it is a bitwise operation, vector operation. And so you're going to do for each element in the array, you're going to do the 1 divided by 1 plus the other, right? For each. It's not rocket science, but this is where you need to properly align on 1 minute, 10 minutes, etc. Otherwise, you would be totally, you know, it wouldn't make any sense. How do you divide these two things if they are not already aligned? So this is what this is what happens with those bracket expression that we call an iterative expression. And so you want to show it in percentile, so you're doing 100 times this. So if you switch to this, and this is also really nice, is the ability to look at your data and look at your intermediate results. And this is something that not a lot of products offer, is to be able to verify your calculation. And you know, me as a next data scientist, it's important to say, okay, you tell me that it's 100 of this divided by that, but you know, let me show the input and verify that the output are actually matching. And it's good to have this intermediate step of the calculation. So you see my request CPU. This is the source data, my CPU allocatable, and then I called it expression, and this is a calculated thing, and it's roughly, you know, 2000 divided by this. It sounds okay, right?
Yeah.
I have this for every cluster. And so what you want to do at this point, and so what I was saying is it's not looking nice because the notebook doesn't know which one to chart. So it's charting all of them. So it's charting request, allocatable, and expression, each 3 lines for each cluster name. So here at this point, what you need to do is to fields remove CPU allocatable and request CPU. And now you have something that looks good, because now you were expecting something in the 100%, right? And indeed, so here is something that we need to improve. We need to show percentage here. And because it's a calculation, we cannot derive, we cannot infer, so we will provide something for this. You would set it up in the settings. But you see that, well, this one, beta, is the one that is the most trained at 45%, and GKE is doing fine at 22% of usage. Okay, so this is the one thing that we just got out that is available already. Documentation is ready for that, and I'm very proud of it. So now I'm going to show you another usage of that I'm going to type very quickly. Another usage of mathematics. So this time, I'm doing a count metric. So it's a count metric is something that you tend to sum. You know, it's the number of requests that you got. And so here it's the number of load balancing thingy on the last 2 hours, and you as you would expect, so they are somewhere. Obviously, the more you enlarge, so you notice this 1000, right? Here, because you're summing and you're, as we discovered, you're extending to 10 minutes, so you're summing more. 7,000. And if you go 7 days, obviously, same thing, you're going over the roof. It's not telling you, it's not giving you an idea of what's happening. So this is where, you know, if you're a metric user, you know that actually when you are doing count metrics, you're not interested in the absolute value, you're interested in the rate. So what we could do here is to divide the number, the sum, by the interval. And the interval is going to always change. And then I want to have it at 1 minute.
So that means the interval is a variable that is available. And
yes.
Yeah, perfect.
We've seen it. It's here. For list. Here.
It's implicitly there. Yeah, it's implicitly there.
So if you do this now, you're going to get yours around 600. If you are on the last 24 hours, you're still on the 600. And if you are on the last one. So I'm making this like a crazy thing. So this is so used that actually we will provide this as part of a language. So we're going to say sum as a rate. But what I'm saying is that we can already do it today with arithmetic expression. Okay.
That's really cool.
So
Thank you so much. Yeah.
that's and so here you don't see it, but I tried it on our production environment, and you could really see some seasonality, that it was going up and down, and that there were time of the day where it was more used, and you had to enlarge it, but it was important to have this integration. Okay. I want to show another thing that is less time series, but still it's showing more like the power of, okay, what about the rest of the data? So here I was always assuming that everything is like, you don't need logs, you don't need nothing, you don't need an entity, but actually you do. it's the power of Dynatrace, right? So you know what I know about disk, host disk, etc., is that not all the information is on the metric. Sometimes you have to grab some information from outside, from Smartscape. So I'm going to, as usual, entity host. Disk, okay. So a disk has 2 dimensions, as opposed to host CPU, which has only 1 dimension. You can have several disks per host, okay? So imagine I have all these disks, and this is what is available. 152 disks, and here you see I have 180 gigabytes already, and it's fairly constant. Okay, so what I want to do is to bring some information about the host, and in particular the tags. So this is where, and it's kind of what has already been shown by Peter. It's the lookup. So you're going to grab from the host. You want the tags, and you have to say, okay, my source field is DT entity host. No, I don't know why I did DT entity host. I type it twice. So here I brought the tags, and if you look at the record list now, for each disk, I'm grabbing all the tags that are on the host.
On the host, yeah.
Okay? And the tags are arrays, right? Here, written here. So for this thing, I need to expand the tags, to transform them and to unpack them. Okay, and so I know that I'm actually interested into a certain type of tags. So I'm going to filter when the tags look like AppSec. Okay, and so now if I go back to my line chart, you see I was able to say, okay, all these disks, they belong to hosts that are of a certain tags. And now what I want to show you is, and it is yet another advanced feature, is that I want to further summarize on it. Okay, so I want to continue to apply a transformation. So here, this is where it's powerful, I think, is we did one time series command, but then it's just standard DQL. So just in the same way that we could do calculation between several metrics, for each slot, we can also summarize within within each series. So I can do the sum of the metric one by one for each of these data points and by tags. And John, I forgot to add the interval. So this is one thing that I would like to improve is it doesn't know that it's a time series. So you have to say, oh, by the way, don't forget the interval time frame. And now you see, I have re-summarized the data. And I would have liked to do this in one go, but it's not possible because the tags were not on the data. Okay, you had to fetch it. So it's showing you how powerful it is. You can indeed bring all the data and continue to filter on things that are not on the time series initially, and you can further summarize. Okay, so this is really advanced
so
stuff.
to recap, Fabrice, just to recap this query here, what you are telling me is we obviously have metrics on disks. Disks are attached to hosts. Hosts have metadata. So here you're saying, give me the available disk space for all the disks that are on hosts where we have a particular, let's say, AWS tag on it with AppSec, and then split it out or split it out by the tag itself. So I see we have hosts that run that are tagged with .NET, with Java, with Node and PHP, and now I see the available disk on all the hosts that have these tags. It's really cool.
Yeah, so we're getting into advanced territories, but we see usage of this. You know, it's really a toolbox. So most of the time you won't have to go all the way. But if you need to further summarize, we have all the tools in place in a very elegant way. Apart from the fact that I had to re-specify interval and time frame.
Of course.
I would like, maybe we will do something about this because this does not feel natural. But it's because summarize is something that works for everything. So it doesn't know about time series, just like time series does. But anyway, you see the point. You really
see the point,
a lot of power. And so if I go back to my record list, you see, I have my 4 lines, but they were 118 lines before. And yeah, it's really cool, I think.
It is really cool.
Okay, I'm going to accelerate again. If I can. So this time, I want to just show you this happened in action. So this is, I told you, if you want several time series, there is this append command. So this is going to be a lot because now, you know, same thing, you have idle for each host and then user. So we're going to pick one, okay? This one, for instance. And so now you have what you would expect, you know, your 3 lines. But here, what you did is, you know, you want to focus on a host. You're not focusing on a metric, you're focusing on a host. And here, you would typically open with. So I'm doing a bit of dashboard after all, why not? And Thomas again would be much better. But you know, you add if you're happy, because in the end you don't want to spend your life in the notebook. At the end, you want to put this on a nice dashboard, and so you would put this and you would have your nice thing. And I suppose we would have a host as a variable, and it would change automatically. I don't know, but I'm sure we can do something with the dashboard as well. Okay, so this is one usage, not advanced usage, but a typical usage of time series in combination with, you know, and again, you have this building block time series, and then you do a bit of summarize, a bit of append. So it's pretty cool. Now, another thing is, all this, like everything is metrics, and it only works on metrics. No, actually, we are applying the same principle. So fetch logs, I know this actually. You get your logs. Well, you can turn this into a time series with this make time series command, which is really cool also. So, and you say count equals count. And you want to count log level, let's say.
Mm-hmm.
And you see,
yeah,
in one command, I was able to give you the number of, severe, looks like something is going on, one, notice, info error. So something is happening. Maybe you would put a rate on this.
yeah.
You would divide by interval.
Quick question for you though. So the
Yeah.
difference between the make time series and the summarize, because the summarize would also allow me to do the same thing. But
Yes.
the difference is it behaves then as a time series, meaning with the interval, with the
Yes,
start and
exactly.
the end time,
You
and
got it.
then you can do, okay, that's awesome. Yeah, perfect.
No,
I
it's
got
really
it.
cool. It's exactly that. And so if I do last 24 hours, I will get, and so here it would make sense. So something is happening, I can see now, but your count is going to increase. But you see, if I look at the record list, you see interval 10 minutes. So it has aggregated more.
Yeah, that means the make time series comment also probably has an optional interval parameter.
Yes, it does. You could do it by day. So in between, obviously, this is really too crude. You would have put plenty of filter in
of
between.
course.
You're looking at something in particular. So I did it the reverse because I wanted to only show make time series. But normally you would have done fetch logs, filter,
Perfect.
and then you say, okay, now I'm good, make time series. Okay. Then so that's one thing. And then obviously on your count, you can multiply by 100, you can divide by etc. Exactly the same. So everything that we've shown, and this is what I was explaining, time series to do the fetch, to do all the data messaging that needs to happen before, and then everything is DQL, everything is common thing, and it's nothing specific.
Very cool.
Okay. One thing is people very often they say what metrics are available. So this is at the moment something that we have to improve on. The only way really from DQL where you can figure out what's available is to use the autocomplete. You use control space and you refine, but and then it's going to provide you with a list that matches what you typed. We're going to improve this to have something that is similar to the metrics browser, where you have a list with all the definition, and it's also going to come with Thomas Siegerbecker assisted tool. But once you have, and in the same way, if you do the list of dimension is also something that appears. You have to insist a little bit, but you see all the dimension that you could use in your filter, in your pre-filter, or that you want to aggregate by. Okay, so this is something that is available, but it's not. We will improve the usability on this, but in case people ask. To find the metrics and to find what's available on the metrics, at the moment you need to use the autocomplete until we have Thomas query builder, as he calls it. I want to show one more thing. So switching to, and then I will be mostly done. But in the Data Explorer, so this famous CPU usage that you can split by, so we need to provide something equivalent in the notebook. But you have this, so for those users that are familiar with metric selector, they can go there as a starting point and then use the open with from here, and they will get the exact the converted expression into DQL.
That's perfect. Yeah, that's a good way, as you said, until we have this baked into notebooks and dashboards, the Data Explorer is still there and is still a good option to get started. Yeah, really cool.
Yeah, here you have on the metric you have the classic open navigation that you have, you know, that have been already shown by Peter. But this is as long as you have the information, then you can do all the navigation that you would expect. There is another way to find the metrics. Is again
metrics browser.
In classic, you have this supported in Grail, and so you can see what's available, and you can also open with from here. Okay,
perfect.
So it's, you know, because I'm hearing often, is it available? Yes, it's there, and yeah, that's these are the typical questions that I get. I want to actually well, at this point I'm finished. I want to point to the 3 things that are in the presentation. No need to switch to the presentation. I'm going to, I have them already open here. The 3 links, they are these built-in metrics, that are already, the content that is already available in Grail. It's also on the web page. So it's one of the 3 links that I provided. So if you knew, you know, what metrics key you are using, and you want to start building a dashboard or a notebook in Grail, then here is, you know, the before and after. So I guess we had a presentation where it was explaining it, but we renamed it. The colon has been removed, and it's more or less built-in colon into DT dot. And also we took the opportunity to snake case everything and to make it a bit more consistent. And there are more differences. So, but all this can be, you know, it all goes to the same place. You know, transpiler. It's always trying to do the same thing, like to facilitate the migration.
Makes sense.
The documentation is explaining the time series here. That's another link. So there are additional parameters that you can tune when we introduce the rate parameter, so that you don't have to do this division by the interval. It's going to be shown here, and then some examples. So similar to what I did. It's all the typical use case and multiply are here.
Cool. And we also add the links to the description, so it's easier for you to find, but I think they're all very easy to spot in the documentation. Fabrice, thank you so much for this. This was, first of all, a great initial introduction on how time series data internally works in Grail and how DQL works, and then just great examples. And we will share the notebook that you've created, so all the examples that you showed today will be shared. We'll put them on the Discover Dynatrace Playground tenant, and the link to this you will also find in the description of this video.
Okay, excellent. Thank you very much.
Thank you.
That's great.
I'll hope to have you back next time. Exactly. Bye-bye.
Cheers. Bye.